Today we have section 5.1, day 1. The section total overall is operations with polynomials. Today we're focusing on exponent properties and simplifying monomials. If I get going too fast for you on this chart of properties, you can always just hit pause, or you could look in your book. It's exactly the same pretty much. I just kind of changed it to numbers or letters that I liked better. So our first property is the product of powers. Product because you're multiplying, and powers. We have a common base, x to the a times x to the b. If the letter or the number down here is the same, the big letter or the big number is the same, then we can add our exponents. So this is going to be x to the a plus b. Over here we have 5 squared times 5 to the 4th. Okay, so it would end up being 5 to the 6th. 5 to the 6th. Quotient of powers. Okay, we could divide, and just like we add them for multiplication, when we divide, we're going to subtract our exponents. Okay, x to the a over x to the b, so we're going to subtract our exponents, a minus b. If we had 5 to the 8th over 5 to the 3rd, we'll have 5 to the 8 minus 3, or 5 to the 5th. How come that works like that? Okay, if I have 5 to the 8th over 5 to the 3rd, that means there are 8 5s. 1, 2, 3, 4, 5, 6, 7, 8. 8 5s up there, 3 5s down here. So those would cancel out, and I'm left with 1, 2, 3, 4, 5. 5 5s, 5 to the 5th power. Same way with when you're adding them, right? Or when you're multiplying them together here, if I had 2 squared times 2 to the 3rd, that's 2 times 2 times 3 2's. Total there are 5 2's, 2 to the 5th. So that's just another way to illustrate that so you can see that a little more clearly. Negative exponents. Okay, if I have x to the negative a, I can make that exponent positive and put it on the whole thing on the bottom of a fraction. Do the reciprocal. Okay, the negative exponent is just a signal to do the reciprocal. 4 to the negative second is going to flip over and be 1 over 4 to the positive second. 1 over 3 to the negative 4th is going to flip back up to the top and be positive 3 to the positive 4th. Alright, then we have power of a power property. X to the a, parentheses to the b. So we have something to an exponent, parentheses to another exponent. We get to multiply those exponents together. Okay, so I have 2 to the 3rd, 2 squared to the 3rd power. That's going to be 2 to the 2 times 3 to the 2 to the 6th power. Power of a product. If I have 2 things, or either 3, 4, 5 things inside parentheses all being multiplied together, then to a power, to a, I can take that exponent in to all the things being multiplied in that set of parentheses. 4w parentheses squared is going to be 4 squared times w squared. Same idea here with fractions, with division, power of a quotient. If I'm dividing things inside parentheses raised to a power, I can bring that exponent in to the top and to the bottom of that fraction. 2/3 squared is going to be 2 squared over 3 squared. You could then simplify those exponents. And the 0 power, anything raised to the 0 power will always come out as 1. Simplifying monomials. This is how you know when you're done with your homework today. When you have no power of powers left, when each base, each big letter or big number appears only once, All the fractions are in simplest reduced form, and we don't have any negative exponents left. We want happy positive exponents. Happy positive exponents. Okay, so those are our rules and our properties for today. Let's take a look at some examples. Let's say if we had 2a to the negative second times 3a to the third b to the third times c to the negative second. Okay, go ahead and pause and give that one a shot. Okay, so how I would do this is I'm going to do each one of these separately. This is going to be 2 over, this is a negative exponent, so now it's going to go on the bottom. These were all positive, they're good to go. We stay with 3a to the third, b to the third, and this is a negative exponent, so it's going to go down to the bottom. Okay, now I'm just multiplying fractions. We're just going to multiply right across. 2 times 3 is going to be 6. A to the third, b to the third. Then on the bottom we'll have our a squared, c squared. Am I done? Nope. I have that a listed twice. I have an a on the top and an a on the bottom. Now I get to use my quotient of powers property. I have a to the third over a squared, so I'm going to subtract 3 minus 2. I'm dividing, so I get to subtract those exponents. So I have 6 a to the first, b to the third, all over c squared. Alright, hopefully you see how that works. Let's try out another one. What if we had negative 2 x to the third y squared parentheses all to the 5th power. So it's parentheses to the 5th power. Okay, this 5 is going to come into everything. Alright, so this is really negative 2 to the 1st power. So when I multiply my exponents, I'm multiplying 5 times 1, 5 times 3, 5 times 2. So this is negative 2 to the 5th, x to the 15th, y to the 10th. Okay, we're going to multiply our exponents there. Negative 2 to the 5th. Okay, 2, 4, 8, 16, 32. It's going to be a negative 32. That was a good one there with our power of power property. Let's see if we can do one with